Welcome. Today we discuss some problems on three-dimensional geometry. Our first problem is the image point of A, whose coordinate 163, with respect to the line L x by 1 is equal to y minus 1 by 2 is equal to z minus 2 by 3 is options 211. Second one is 125. Third one is 107, 017. Now let us see what is the problem and how to solve it. Actual problem is one point A, 163 is given and one straight line is given that in 3D. We have to find the image point of that given point A with respect to that straight line. So suppose this is the line L and the given point A 163 is that. We have to find its image point. How to find it? Now from here, perpendicular is drawn on the line and extend it. If that length is equal to this length, suppose this point is B and that point is C. If AC is equal to BC, then B is the image point of A with respect to L. Mind that this straight line AB is perpendicular to the given line L. Suppose it is alpha, beta, gamma. We have to find it, alpha, beta and gamma. So suppose any point on that line, we find any point on that line. For that purpose, let us suppose it is R. So any point on that line AC, x is equal to 1 into R, that is R. Y is equal to 2R plus 1. And Z is equal to 3R plus 2. This is any point on that line AC. It depends on values of R. We find such a value of R so that this point lies on the line L. So in that case, C will be that point. So we get C is that for a particular value of R. So now, direction ratio of AC. Direction ratio of AC, this is C minus A, that is R minus 1. 2R plus 1 minus 6. 2R plus 1 minus 6. And 3R plus 2 minus 3. So that 3R minus 1. This is direction ratio of AC. Now as because AC is perpendicular to the line L, this line, therefore we must have dot product of direction ratio of L and direction ratio of AC. Dot product will be 0. That is 1 into R minus 1 plus 2 into 2R minus 5 plus 3 into 3R minus 1 must be 0. From that, very easily we can solve for R. This is r plus 4r plus 9r, r 2r into that, is equal to, take all the constant into that side, 1 plus 10 plus 3, that is 14r is equal to 14, hence r is equal to 1. So that now it is clear that for r is equal to 1, this point C lies on that line L. So actually C, coordinate of C in that case is equal to, put r is equal to 1. So 1, 3 and 5. So C is equal to actually 1, 3 and 5. Now this is actually foot of perpendicular of this line on L. To find B, image point actually it will be such that C is the midpoint of AB. Therefore, this one will be equal to 1 plus alpha by 2. That gives us alpha is equal to 2 minus 1, that is 1. Similarly, 3, y coordinate, is 6 plus beta by 2. That is, beta is equal to 0. 6 minus 6, etc. Then 5, z coordinate, 3 plus gamma by 2, that is 10. Gamma is equal to 10 minus 3, that is 7. So alpha, beta, comma gamma is 1, 0, 7. So this is correct option. Now let us take the next problem. So the next problem is the foot of perpendicular from A, point A, and point A is I plus 2j plus 3k, to the straight line L, which is equal to, R is equal to 6i plus 7j plus 7k plus t times 3i plus 2j minus 2k. And options are 3i minus 5j plus 9k, 3i plus 5j plus 9k, 3i minus 5j minus 9k, and 3i minus 5j minus 10k. These are the options. Here the problem is almost like before, but only difference is that this is given, the point as well as the line, they are given in vector terms. Suppose, first of all, let us try to write it in Cartesian coordinate form. This is a straight line. It passes through 6, 7, 7. And its direction ratio is 3, 2, minus 2. So its equation in Cartesian form is x minus 6 by 3 is equal to y minus 7 by 2 is equal to z minus 7 divided by minus 2. This is Cartesian form of that. Suppose this is the line L. That line L is this. and A is the point whose position vector is this, means A is equal to 1, 2, 3. Perpendicular is drawn on it, let it be B. So we have to find the coordinate of B in vector form. Suppose in Cartesian form it is alpha, beta, gamma. So direction ratio of AB, which is equal to alpha minus 1, comma, beta minus 2, comma, gamma minus 3. And sorry, just 1 minute. Actually, beta is that, okay. First of all, I assume that B is a point on that line as well as on this line. So we find it as, suppose this is R, therefore coordinate of B is nothing but x coordinate is 3R plus 6, y coordinate is 2R plus 7, z coordinate is minus 2R plus 7. Okay, so this is coordinate of B. We have to find it out. Clean it. So now, direction ratio of AB. B is that and A is this. So direction ratio of AB, it is like before. This is this minus 1, that is 3R plus 5. This is 2R plus 7 minus 2, 2R plus 5. This is minus 2R, 7 minus 3. This is direction ratio of AB. But the straight line AB and L, they are perpendicular to each other. Though corresponding components of direction ratio, their dot product must be equal to 0. So that we get 3 into that plus 2 into 2R plus 5 minus 2 into minus 2R plus 4, that must be equal to 0. That is 9R plus 4R plus 4R is equal to minus 15 minus 10 plus 4. This is 8, sorry. This is 8 in that side. This is minus 8 in that side. So that it is, we get 8, 9, 17R is equal to minus 17. So R is equal to minus 1. So if we put R is equal to minus 1, then we get the coordinate of B, this one, which is nothing but foot of perpendicular. So the required foot of perpendicular is 5. Minus 10 plus 6, so 3. Minus 2 plus 7, 5. This is plus 2, 9. So this is actually equal to, this is given, now calculated in terms of Cartesian coordinate. So its vector, in case of vector equation, its position vector B will be 3i plus 5j plus 9k. This one, 3i plus 5j plus 9k. So second option is correct. Next, the shortest distance between the straight lines x minus 2 by 3 is equal to y minus 2 by 1 is equal to z plus 1 by 2, and x minus 1 by 4 is equal to y minus 2 by 2 is equal to z minus 3 by 3. Shortest distance between these two straight lines is how much? Option 9, 8, 9 by root 4, 9 by root 6. The two straight lines in Cartesian form are given in 3D. It is lying in a plane, this is lying in another plane. Therefore, their perpendicular, their distance, the minimum distance, we have to calculate it. If the straight lines are in a plane, suppose plane on the board, then if they are not parallel, the minimum distance will be 0. We have discussed what is the formula for calculating shortest distance. I think you can remember this is shortest distance is equal to x2 minus x1, y2 minus y1, z2 minus z1 by 3. I mean it is a1, b1, c1, a2, b2, c2. That divided by k. What is k? I will tell you. What is x1, x2, b1, b2, etc. This straight line, actually, it is of the type x minus x1 by a1. So x1, y1, z1, x1, y1, z1 is the point through which first line passes. Similarly, for second line, it passes through x2, y2, and z2. This is x2, this is y2, this is z2. This is a1, b1, c1, and a2, b2, c2. And k, actually, it is equal to root over of that k. Is root over of, it is cofactor of this element, that is b1, c2 minus c1, b2 whole square plus cofactor of that is this into this minus that is c1, a2 minus a1, c2 whole square plus cofactor of this a1, b2 minus b1, a2 whole square. So this is the formula, and from the given straight lines, all are known, x1, y1, z1, a1, b1, all are known. So we find that this determinant is equal to, first I calculate this determinant, it is equal to x2 minus x1. This is x2, this is x1, minus 1. Minus 2, it is 0. This is this minus, it is 3, it passes through 3, and it is passing through minus 1. So minus 4. And a1, 3, 1, 2, 4, 2, 1. So that it is equal to minus 1 into 1 minus 4. 0 into something is 0. Finally, minus 4 into 6 minus 4. So that it is equal to minus 3 plus 3. And this is equal to 2 minus 8. So that it is equal to minus 5. Just now, I check it. It is actually 1 minus 2, so that it is minus 1. 2 minus 2, 0. It is 3 minus 1, so this is 4. This is 3 minus 1. 3 minus 1, so it is 2. Sorry, very sorry. Once again, 3 minus 1. That is 3. It is 3 minus 1, 4. So that it is 4. So that calculation should be rectified. Plus 4. Yeah. Answer is 9 or 10. 2. It is minus plus 3. This is 4, 8. This is minus 3 plus 3. Okay. And this is 2, 8 plus 8. This is 11. Now actually answers are not like that. As again I have some I did some mistake. Anyway, now calculate k. K is root over of cofactor of this 3, 1, 2 and 4, 2 of this is 3. My mistake, again another mistake is there, 4, 2, 3. So that this is equal to 3 minus 4 whole square plus its cofactor 8 minus 9 whole square plus this one is 8 minus 9 whole square. Cofactor of that 6 minus 4 whole square, that is 6 minus 4, that is 2 whole square, 4. 4, 5, 6, so root 6. And this one is equal to, as because it is 3, our answer is minus 1 into this is minus 1 into 3 minus 4. 3 minus 4. 0 into something is 0. Plus 4 into 6 minus 4. So that it is 1 plus 8 is equal to 9. So answer is determinant divided by k, 9 by root 6. 9 by root 6, this one is answer. Actually, it depends on calculation. You should calculate it cautiously. Anyway, next problem. Our next problem is shortest distance between, again shortest distance between R is equal to 2I plus j plus 3k plus t into plus t into 2I minus j plus k. And second equation is R is equal to 3I minus 2j plus k plus s into minus I plus 2k. Two straight lines are given in vector form. First straight line, it is equal to a1 plus t times b1. The vector, this straight line passes through this point 2, 1, 3 and parallel to this and direction ratio is 2 comma minus 1 comma 1, and for the second one same type. Options are, this is root 15 by 2, root over 21 by 2, and root over 21. For vector equation of shortest distance is equal to, formula is a2 minus a1, all vector sign, dot product b1 cross b2 by magnitude of b1 cross b2, its magnitude, and a modulus sign. It cannot be negative, that's why. This case, first straight line is that. So it is A1, and this is B1. This is A2, this is B2. So using the from this, using the results, you put it there. So shortest distance is equal to A2 minus A1, 3 minus 2i, 3 minus 2 into I, minus 2 minus 3j minus k minus 3k. This is minus 3, this is k minus 3k minus 2k dot b1 cross b2. b1 actually equal to, this is b1, so 2i minus j plus k cross minus I plus 2k divided by modulus of this thing. So first of all, we find the cross product of this and that. It is equal to, it is b1 cross b2. It is equal to I, j, k. First one is 2 minus 1, 1. And it is equal to minus 1, then 0, then 2. b1 cross b2. It is equal to I minus 2 minus 0. So minus 2i, j component, minus 1 minus 4. So minus 5j, minus 1 minus 4. K component, 0 minus 1 into k. This is this in cross that. Magnitude of b1 cross b2, it will be equal to root over of minus 2 whole square minus 5 whole square, that is root 30. So that shortest distance is equal to this dot that, means this dot that, that is, it is equal to I minus 3j minus 2k dot, this is equal to minus 2i minus 5j minus k divided by root 30, its modulus value. It is equal to minus 2 plus 15 plus 2 by root 30. It is equal to 15 by root 30. This is equal to, it is root 15 into root 15. This is root 2 into root 15. Root 15 cancels, so that root 15 by 2 within square root. Oh, sorry. I think this is root 15 by 2. Second option is that. Next. Now next problem. Today is very hot. The value of A for which x minus 1 by 2 is equal to y plus 1 by 3 is equal to z minus 1 by 4 and x minus 3 by 1 is equal to y minus a by 2 is equal to z by 1 meet at a point is. Two straight lines are given here. First straight line, second straight line. This straight line passes through 1, minus 1, 1 and its direction ratio is 2, 3, 4. Similarly, for the second straight line, it passes through 3, a and 0. It is actually nothing but z minus 0 by that and its direction ratio is 1, 2. So in this case, one unknown a is there. We have to find the value of a so that they meet at a point. In 3 dimensions, they may not meet. Given that they meet, and then what would be the value of a? For that purpose, let us suppose this is your R and this is your S. From there, options not yet given. 3, 5 by 4, 7 and 9 by 2. So we suppose that this is R and this is S. So any point on that is 2R plus 1, 3R minus 1, 4R plus 1. This is any point on it. And any point on it is S plus 3, S plus 3, 2S plus A, and S plus 0, that is only S. So this is any point on it and this is any point on it. It depends on values of R and S. Suppose we have to find a particular value of R and particular value of S so that these 2 points are same point, then it means they will meet. That is, we assume that 2R plus 1 is equal to S plus 3. They are same point, so this component is equal to that component. Similarly, 3R minus 1 is equal to 2S plus A, and this is equal to this is equal to 2S plus A, and 4R plus 1 is equal to S. Now, 3 equations, 2 unknown R and S, and A is another type unknown. Solving this and that, we can very easily solve for S and R. Now, as because they meet, these values of S and R satisfy, and in that case, in putting the value of R and S in that equation, A can be solved, which is our required answer. Now, solving this and that, actually by subtracting this minus that, minus 2R, this minus that, this and that I am taking, 1 cancels, is equal to this minus this 0, so 3. So actually r is equal to minus 3 by 2. Putting these values of r is equal to minus, so we get s is equal to 4r plus 1, that is 2 into 2r plus 1. 2r means minus 3, 2r is equal to minus 3 into 2 plus 1, so that it is minus 5. So that we get r is equal to minus 3 by 2, s is equal to minus 5. As because they meet, these two straight lines meet, so for these values of r and s, this also must be satisfied. That is 3r minus 1 is equal to 2s plus a. 3r means 3 into minus 3 by 2 minus 1, 2s minus 10 plus a. 2s is equal to that. So that it is minus 9 by 2 minus 11 by 2 plus 10 is equal to a. So that a is equal to 20 minus 11, 9 by 2. So 9 by 2. So that a is equal to 9 by 2. For these values of a, they meet at a point. This is answer. Next. It's just 1 minute. So next problem is the point of intersection of x minus 4 by minus 2 is equal to y plus 2 divided by 1 is equal to z minus 7 by minus 4. And x plus 6 by 4 is equal to y minus 1 by minus 1 is equal to z plus 1 by 2 is point of intersection of this straight line and that straight line is how much? It is, options are 2 minus 1, 3, 2 minus 1 minus 3, then 2, 1, 3, then minus 2, minus 1 and 3. Yes, this is plain problem, very simple problem. Two straight lines in Cartesian form are given and we have to find their point of intersection if exist. So previous method we will follow. Suppose this straight line, in that straight line this relation is equal to r and this is equal to s. Any point on the first straight line is minus 2r plus 4, minus 2r plus 4, comma, r minus 2, minus 4r plus 7. And for second straight line, any point is 4s minus 6, minus s plus 1, 2s minus 1. This is any 2 points on them. Now we have to search for R and S, particular values of R and S, so that they meet. This point, a particular value of R, this point depends on R, this point depends on S. We find the particular value of R and S so that they are equal. This is equal to that, this is second one, this third one, they are equal. That means we get minus 2R plus 4 is equal to 4S minus 6. R minus 2 is equal to minus S plus 1, and minus 4R plus 7 is equal to 2S minus 1. Now 3 equations and 2 unknowns are there. Solving any 2, we can very easily find R and S. If for that value of R and S, third one also satisfies, now we can say that they meet, and meeting point very easily can be obtained. Now solving these 2, this is minus 2R plus 4 is equal to 4S minus 6. Now multiplying this by 2, 2R minus 4 is equal to, I am multiplying this by 2. So minus 4 is equal to minus 2S plus 2. Now adding them, we get 2R cancels, this is cancelled, so 0 is equal to 2S minus 4. They together is 2S, they together is minus 4. So S is equal to 2. And putting these values of S, 2 in second equation, we get R minus 2 is equal to S means minus 2 plus 1, so that R is equal to 1. So we get S is equal to 2, R is equal to 1. Now let us see whether this one we obtain from this first and second relation. Now if these values of R and S also satisfied by this equation, then we say that they meet. Now putting these values of R is equal to 1, R is equal to how much? R is equal to 1. So minus, here it is minus 4 plus, that is 3, and this is 4 minus 1, that is also 3. So these two values R and S, R is equal to 1, S is equal to 2, is satisfied by the third equation. So we can claim now that they meet at a point, and the meeting point is either this or that by putting the values of R1 or S is equal to 2. Putting R is equal to 1 here, it is equal to minus 2 plus 4, that is 2. This is 1 minus 2, that is minus 1. And this is minus 4 plus 3, that is 3. 2 minus 1, 3 is meeting point, that is point of intersection of that. So this is correct option. So today is up to this. I request you to like and share the video and subscribe it if not yet subscribed. Thank you.